Hello, very good afternoon to one and all present. This is Jigar Ratnottar from Atmiya Engineering College. Today we are going to solve the paper GTU question paper year 2010. So just starting. The question number 1, calculate the value of resistance. This is a 2 marks question, so each question contains the 2 marks. This is the short questions. Number 1, the calculate the value of the resistor having the color bands as per the Indian national flag, color code of the resistor. Question number 2, explain the term the reluctance. What is reluctance for the magnetic circuit? Question 3, the Fleming's right-hand rule. The question number 4, what is the Q factor and the which parameter it depends? The question number 5, in RLC circuit, series circuit, at the resonant voltage across the inductor is 300 volt, then the supply voltage is 230, then find the voltage across the capacitor and the resistor. On which factors? Question number 6, does the capacitance of capacitor depend? Question number 7, the relationship, find out the relationship between the line current and line voltage, phase current and phase voltage for the 3-phase circuit. Connection is star and delta. So now solve the questions one by one, starting with the question number 1, color code of the resistor. Resistor values are marked into the body of the resistor using a series of colored band. All the resistor, whatever you see, they are marked with certain kinds of the colors. Now this gives the value of the resistor. These colors are give the value of the resistor and other information related to the resistor, like a tolerance and sometimes the temperature coefficient. So there is no need to find out anytime the value of the resistor with using the multimeter. You can also measure the value of a resistor with using the color code technique. So here we are just going to know how the color code is useful in a resistor. This is the figure where you can just see the diagram of the resistor. The different colors are marked into the body of a resistor. Generally, the first, second and third are the digits applied for the values of a resistor. The fourth one is used for the tolerance. This is the indicated with the color code for the resistor. Different kinds of bands you can see easily. Now just go through one videos. According to that video, you can easily find out the value of or solve the value of a resistor.
Color code for resistors. A circuit device made to have a specific value of resistance between its ends is called a resistor. Resistors in the range 0.01 ohms to 10 to the power 7 ohms can be bought off the shelf. The resistor is marked with the standard code using 3 or 4 color bands according to the color scheme shown in the table. Click on the button to view the table. The first 2 bands represent the significant digits. The third band indicates the decimal multiplier, and the last band stands for the tolerance level or the maximum power that it can dissipate. This resistor has a value of 47 kilo ohms and plus or minus 10% tolerance. Let us try to read the value of this resistor. From the table we know that the first band, that is yellow, corresponds to 4. Violet corresponds to 7. The third band, which is a multiplier, corresponds to 10 to the power 3, and the last band, which is silver, tells us that the tolerance level is plus or minus 10%. The value of this resistor is 47 into 10 to the power 3 ohms, plus or minus 10%, or it is equal to 47 kilo ohms plus or minus 10% tolerance. Here is a mnemonic, the art of improving memory. B.B. Roy of Great Britain had a very good wife. Now try to calculate the value of the resistors displayed here.
The B.B. Roy goes to Bombay via Gateway. This is again one of the short form of the color code technique. So according to that statement and the color code schemes, you can easily identify whatever the any kind of resistor the values. Now move towards the next question about the reluctance. Reluctance is a term related to the magnetic field or the magnetic material. Reluctance is the property of any kind of magnetic material to oppose the magnetic flux produced by itself. See, the magnetic material has the capacity to produce the magnetic flux due to itself, or whenever the current passing through it, or energy excited from any external applied electric field. So the property of that particular material to oppose itself magnetic flux, then it is known as a reluctance. So the amount of opposing the property of the magnetic field, that one is related to directly the reluctance. The second definition of the reluctance, it is the ratio of magnetomotive force, which is short formly known as a MMF, to the generated magnetic field. So if you are taking the ratio of MMF towards the magnetic field, then you can easily find you can also find out the value of reluctance. Reluctance is denoted as the symbol S, capital S. So according to the definition of 2, we can find out the value of S is S equals to MMF magnetomotive force upon magnetic flux. The unit of reluctance S is AT by Weber. The next question 3, the Fleming's right-hand rule. The Fleming's right-hand rule shows the direction of the induced current. So whenever you have to just find out the direction of current, then the Fleming's right-hand rule is very useful. Whenever any current carrying conductor moves in a magnetic field, then the necessity of finding the direction of the current, then this rule is very useful. The right hand is held or the kept such like that the thumb, the first finger and the second finger, they are mutually perpendicular or with the 90 degree with each other. Now what exactly the first finger, the thumb and the second finger indicates? Let's see. The thumb, which represents the direction of the motion of the conductor. So whatever the motion of your conductor, put your thumb into that direction. Now with the 90 degree of the thumb, put the first finger. So your first finger represents the direction of the magnetic field. So your second finger is again the 90 degree with your first finger, which represent the direction of the induced current or the generated current due to that magnetic field. So you can easily find out, again I am telling you, you can easily find out the direction of the induced current, whatever the motion of your conductor. Just put your thumb into that direction. So your first finger indicates the magnetic field, and your second finger, which is again 90 degree with your first finger, which represent the induced current or the direction of the induced current. See, this is the figure which exactly shows the 90 degree. They all three are the 90 degree with each other. You are where you can find just your thumb represent the motion of the conductor upward, with the exactly 90 degree your first finger, which represent the magnetic field, and with the first finger 90 degree your second finger represent the induced current. So this is the Fleming's right hand rule. To find out, again I am telling you, to find out the induced direction of the induced current in a magnetic field, whenever you are putting the current carrying conductor into the magnetic field. Now just go through one video which can be easily identified the direction of the induced current.
Fleming's right hand rule. When the thumb, the forefinger and the center finger of the right hand are stretched mutually perpendicular to each other and are held such that the forefinger is along the direction of magnetic field B and the thumb is along the direction of motion M of the linear conductor, then the center finger points along the direction of induced current I or electromotive force. Consider a rectangular coil ABCD placed in a magnetic field B due to horseshoe shaped permanent magnet Sn. If the coil is rotated in anti-clockwise direction, such arm AB moves upwards or CD moves downwards, the induced current will appear from A to B in the arm AB according to Fleming's right hand rule. Similarly, in the arm CD, the current will be from C to D. Thus, Fleming's right hand rule helps in determining the direction of the induced current or electromotive force.
Here you can, according to that video, there is no need to only move your conductor in the anti-clockwise. You can also moving the conductor into the clockwise. So according to the moving of the conductor, you have to just put your thumb, your first finger, or you can say that your forefinger and your second finger, so you can easily find out your induced direction of the induced current. Now move towards the next question, the capacitance of a capacitor. It is the capacity of capacitor to store the charge inside the capacitor, then it is known as a charge of capacitor or the capacitance of capacitor. Every capacitor has the capacity to store the amount of charge. So that amount of charge is known as the capacitance of that particular capacitor. There are different kinds of capacitors, so different kinds of capacitance also. Now we know that the charge of capacitor is proportional to the potential difference V between the two plates, the two parallel plates. So whatever the potential difference or the applied electric field outside, then it is directly proportional to the generated capacitance. They are directly proportional with each other. The factors which affects the capacitances, there are generally the four types of parameters which affects your capacitance. First of all, the shapes of the plates. You have to just define the shapes of the plate. They are either the circular, they are either the square, whatever, so that directly your shapes affects the capacitance of capacitor. The next one, again the size of the plates. If your size are this less, the capacitance are less. If the size of the plates of the capacitor are more or increased, then again the capacitance are increased. So the capacitance is directly depends upon the size of plates, so it affects your capacitance. The distance between the two plates, if you kept the two plates are very near, or you can kept your two plates of the capacitor are more distance, then it directly affects your capacitance. Capacitance is two parallel plates or the medium between the two parallel plates of in a capacitor are behave like an insulating material. The last one, the dielectric medium. Whatever I tell you, the dielectric, it means that insulating. So that 4 factors are more affect your capacitance of capacitor. Now just go through a video.
Today's video, I am going to go over what is capacitance. Now, I'm not going to go over how to calculate the capacitance in circuits or how to calculate the capacitance of a capacitor, but I just want to go over a general conceptual review of what capacitance is, kind of definition, the abbreviations, the units, how we measure it, how we talk about it, because when we do problems with electric circuits with capacitors and resistors, there are several different terms that you should have a good conceptual understanding of. One of them is capacitance. Another is current. Then we have resistance, and we have voltage, and we have charge. And a lot of times I think people are doing calculations, they're getting the right answers, but I'm really not sure that they understand kind of in general, conceptually, what these things are. Like, what is current? What is charge? And what is capacitance? Especially when we're doing equations or problems using Ohm's law, V equals I times R. The voltage is the current times resistance, or as I like to call it, the capacitor equation, Q equals C times V, which is charge equals capacitance times the voltage. All right, so today we're going to go over capacitance. Now, capacitance, like resistance, it's kind of hard to come up with a good definition of capacitance. Now, I know, and maybe you have seen these things, these are capacitors. These capacitors have capacitance. The capacitance of this capacitor is 1,000 microfarads. Capacitance is measured in farads. This one is a 10 microfarad capacitor. Most capacitors have a capacitance of less than 1 farad. Okay, 1 farad is a lot of capacitance. Right now, of course, you can get them, but most of the ones you get at the store that you use in electronics have a capacitance of less than 1 farad. Now, what does that mean? That means that they can store charge. That's what capacitors